All right, in this video, we're going to be talking about critical paths and EST. So let's go ahead and get started. Now, first off, what we're dealing with is some vocabulary that we've already seen before. So you should already know, especially if you watched the first video, what is a vertex as well as what is an edge. Okay. Now, something that you may not know, and that is what is a directed edge, which is very simply an arrow on a graph. All right, pretty simple. And then lastly, the two things that we're going to be talking about are what is called the critical paths and what is called the EST, which is the earliest start time. Now, the best way to talk about this is to just go ahead and dive into it. All right. So here's what I need you to think about. All right, and that is this. So take this situation. You have two friends. You have friend one, you have friend two. And and for some odd reason, they're away from the car, and then they're going to start running to the car. Okay. Now the question is very very simple. If, for example, the two friends are running to a car, which person will get there first? So no, this is not a trick question. You would say, well, person one has 30 seconds, so person two has 45 seconds. So obviously, person one will get there first, and you would be correct. But let me throw a little curveball in here. And now let's say, unfortunately, friend two had the keys of the car. When will the car actually get started? So going back to this example, very simple. This friend here, yes, he will get to the car faster. All right, he'll be there in 30 seconds. But unfortunately, friend two had the keys. So what happens is friend one is getting to the car faster, but he's waiting until friend two gets there. All right, and then friend two gets there at 45 seconds, and then the car can start at 45 seconds. All right, so the big takeaway from this situation is, although one person gets to a destination first, whoever's slower is actually setting the time. Okay, so it's actually setting the time. So the car cannot start until 45 seconds. Okay, so keep that in mind as we're dealing with these type of graphs. So here's your first look at it. So John is a builder and owns his own company. He just signed a contract to build a house on the north side of town. Here's a list of tasks that'll be needed to complete during the construction of the house. All right. So what you're given is a list of the tasks that technically you don't really need to do anything about, but just kind of look. So each letter or each letter, each vertex in this diagram represents a certain task. And then the numbers on the arrows, which is called the directed edges, represent how long it takes that task to complete. All right. So what we're going to do is we are going to determine what is the minimum amount of days it'll take to complete the house. All right. So here's what you do, and that is beginning with start. All right, because every graph starts with start, so we got to start with start. Okay. Notice there's a 0 on start. The reason why there's a 0 on start's arrow is because starting is instantaneous. It goes. You know, it's like 1, 2, 3, go. So you would say that A has a minimal start time of 0. All right. So think of it almost like it is think of this graph as almost like it's a map. All right. And so you're sitting on start, and then you're walking down the path. And the 0 and the 7, the 3, all the numbers on the arrow represents what time it'll take to get down that path. So like, for example, if you're sitting on A, and let's say it was 0, to go from 0, and let's say that this next path is just say 7 minutes long or 7 days long, whatever. So you would say B would start at 7. Okay, so as you're moving to the right, it's a continual add. Okay, I do not like how that is kind of right there. So, think of it this way. All right. So what you're going to do, and I actually just paused the video, so I'm probably repeating myself, so I apologize. But what you're going to do is, if B can start at the 7-day mark, it takes 3 days for B to do what it's got to do. So that means C can start on day 10. All right, so again, it's a constant add. Now, this is one of those concepts. Let me pause for a second. This is one of those concepts where I've got to explain it one or two times and it'll click. It may not click right then and there, but it will click, I promise. All right, so we're sitting on C. C starts at the 10-minute mark, or I'm sorry, I keep on saying minute, the 10-day mark, and it takes task C 17 days. What is task C? Framing the roofing. So it's going to take 17 days to frame the roof. Now notice how this graph has now split into two parts. The reason why it's split into two parts is because now tasks can be done simultaneously. So D and E will be done simultaneously. But let's see. C starts at 10. It takes 17 days to do whatever C is. So that means D can start on day 27 as well as E. Okay. Now F is special. What makes F special is now we have two arrows going into F. Okay. So E starts at 27 to E can get to F on day 29. D starts at 27 to, so they both have the same time, so that makes it easy. So if they're both 29, then you would say F is 29. Now I'm going to do another example where that's not always going to be the case, but just stay with me on this. So F can start on day 29. It takes 5 days to do whatever F is. So that means G can start on day 34. H, same way. F starts at 29, 5 days. H can start on day 24. So again, we have two tasks happening simultaneously. G can get to I. So at this point, you should kind of know that we're doing a constant add. So if that's 34, that's 4. This right here is going to be 38. Okay. 34, 3. This ends up being 37. Now, my goodness, it ended up the same way. I can get to the finish line at 41. K can get to the finish line at 41. So these two just happen to work. So this is the weird one where it just happens to work, where they both finish on day 41. So what is the minimum amount of days it will take to complete the house? 41 days. I don't know why I'm writing with my mouse, but I am. So 41 days. Now, what is the critical path of the task graph? Now, this is going to sound like a cop-out, but I don't necessarily like how this question was set up because of the fact there were so many things that was the same. So I'm going to pause on the task graph on this one. Okay, so we're going to hold off on that one. All right, but now let's do another one, and actually let's do the critical path. Okay, so here we go. We have another graph that we don't necessarily have a story behind it, but let's assume there's a story behind this, okay? So all these numbers represent, let's just call this minutes, okay? Now, the biggest thing to remember to get us started, and that is whatever is pointing, or whatever start is pointing to, always is going to have a 0 start time. So notice that start is pointing to A, that's a 0. Start is pointing to B, that's a 0. So that means A and B are both starting their tasks on the 0-minute mark. Okay? Now, notice where C is. A and B are both pointing to C. What that means is both of these tasks must be completed in order for C to get started. Now, this is where you need to pay attention to what we went to here. And that is, you have two friends. One friend is getting there a lot faster than the other, but remember, person 2 had the keys. So here's the thing you need to pay attention to. Even though A got to the car at 30 seconds, the car's not going to start until friend 2 gets there at 45 seconds. So what that means is A is just sitting around waiting on person 2. So basically, the slowest person is going to set the time, okay? So going back to this, notice that B can get to C in 2 minutes, okay? In fact, I want to make that in red just so you know it stands out here. So B can get to C in 2 minutes. But here's the problem. A hadn't gotten there yet. A is going a lot slower because it takes a lot more time to do task A. So what that means is B is sitting around. C cannot start until both A and B get there. Okay? So it's not like B can get to C and then all of a sudden go to D. It doesn't work that way. A and B have to complete their tasks in order for C to get started. So what that means is A eventually gets there on the 7-minute mark. So unfortunately, B's sitting there until 7 minutes. So when can B actually, or when can C actually get started? Until the slowest guy gets there, which is 7. All right. Now, C starts at the 7-minute mark. It takes 4 minutes to do task D. So that means that D will start on minute 11. Now let's go back to E here. And I always like to go by really order of the alphabet. It just kind of it makes life easy. B starts at the 0-minute mark, but if you notice, it's going straight to E. So E can actually start at the 2-minute mark. All right. Now, looking at the finish, again, it's got 2 arrows pointing to it. Whenever you have 2 arrows pointing at something, you know you're going to have to evaluate both of these paths here. So D can get to the finish at the 14-minute mark. E can get to the finish at the 6-minute mark. So the question is, when can the finish actually be finished? Well, E will get there a lot faster, but unfortunately, the project is not going to finish until the last person gets there. So you're only as fast as the last person. So a lot of students are going to see this question and be like, what is the minimum amount of days? Or I guess these are days, not minutes. So they're automatically going to say 6, but you can't do that. The timer stops as soon as the last person gets there. So 14 is the final day. So when will the project finally come to a halt? On day 14. All right. Now, what is the critical path of the task graph? Okay. Now, this is where basically these numbers that you found throughout the graph, you're just highlighting how you got them. All right. So watch this. Like if I was to ask you, hey, how did A become a 0? Oh, because it came from start. Okay. How did B become a 0? Oh, because it came from start. So right here and there, I'm highlighting 2 paths. All right. Look at C. How did C become 7? Oh, because it came from A. How did D become 4? Or how did D become 11? Oh, because it came from C. Now let's look at E. How did E become a 2? Well, it came from B. Notice we have 2 paths. How did finish become 14? Is it because E got to 4? Nope, that's not how it was. It was because D got there. There you go. So you would say your critical path is, we make this a lot smaller here. My critical path for this particular graph is just whatever I highlighted to go from start to finish. So start, I went to A, C, D, and then I went to finish. There we go. That's my critical path. Now let's try another one. So same concept. You have a whole bunch of tasks, and we got to figure out how long it's going to take. Now, what you can do, notice how on this last one, I have figured out all my numbers and then I highlighted after the fact. You can actually highlight as you're going. It might actually be easier. So for example, notice that start, just like the last one, is starting from A to B, or is pointing to A to B. So that means that A will be 0, B will be 0. And you can actually highlight as you're doing it. So, okay, A became 0 because of start, B became 0 because of start. All right, now let's look at C. Let's see, A starts at 0, it's only pointing at C. C is going to have a start time of 7. We're going to highlight. Now let's look at D. Uh-oh, D's got 2 arrows pointing to it. So B can get to D in 2 days. C can get to D in 11 days. But unfortunately, D can't start until both B and C. So obviously, B will get there faster, but D cannot start until the slowest person gets there, which means D's start time will be 11. So again, as you're highlighting, how did D become 11? Because it came from C. let's look at E. E, B's pointing to E, just like in that last one. So B starts at 0, 2. That means E is going to start on the second day. So I'm going to highlight that. Uh-oh, F's got 2 arrows pointing to it. F's got 2 arrows, and I think it's very similar to the last one, wasn't it? Yeah, pretty similar. All right, F's got 2 arrows pointing to it. Let's see. E will definitely get there faster because E starts at 2, 4, that's 6, but that's supposed to be a 6. But if you look at D, D, 3, 14. So when can F officially start? Well, whenever the slowest person gets there. Unfortunately, again, remember the fastest time is dependent on the slowest person. Now look at the finish. Notice that E and F is both pointing to the finish here. Well, let's see. E can obviously get to the finish faster because E starts on 2 days. It takes 4 days to do whatever task E is. So that's 6. But again, you can't finish it until everyone gets there. F is 14, 5, 19. So when can the finish officially be finished? On the 19th. So we're going to highlight, and there is my critical path. Start all the way up top to finish. So how many days will it take to complete the project? It would take 19 days. What is the critical path of this diagram? Start, comma, A, C, D, F, finish. There we go. That's how easy it is. All right. We're going to stop here because I'm looking at the time. It's getting pretty long. But anyway, that's how you do it. Let me know if you have any questions. Thank you.